This is a lake in British Columbia called Pavilion Lake. Looks normal, but when you go underneath, it's got like coral growing in a freshwater lake. And when we look in the geologic record of the Earth, for billions of years, the Earth had these weird things forming. We call them microbialites, where microbes turn the water into rock. And we can learn how the history of our planet developed by looking at how these are forming now. And so we treat it as if we're on another planet, to go research how it is you explore such a hostile environment as this deep, really unique lake.
NEMO is an organization between NASA and a university in the United States and Oceanographic and Atmospheric Administration. Normally it's used to study the coral and the life at the bottom of the ocean, but we use it to simulate another planet. And so for the crew inside, we study their bodies, we study how the biology changes when you live in a pressurized environment and an isolated environment. It changes our immune system, it changes our reaction time, it changes a bunch of fundamental human functions that are the same as we experience on space station and the same therefore that we will experience when we go to other planets. And then the other purpose is when we go outside, we have full-scale mock-ups of a lander on another planet, of the vehicles that will drive us around on another planet or another moon. And we've tried those out in the desert and in other places, but how do you try them out under different gravity? How do you try them out for a very small crew that is separated from all of their support people? And so we come outside of that hatch just as if we were on Phobos, orbiting Mars. And we come outside weighed down, wearing the same sort of equipment with the same mindset to try and develop the techniques so that when my children get to Phobos, they will be able to look at our book and say, ah, this is how they did all these things. This is the right way to build a hatch, build a spacesuit, build a ladder, build a crane, build all the things that we need so that they'll work properly and we won't have made some serious error when we get to the next destination in space.
We have a little underwater sort of spaceship operated by one person to go down about 80 meters in this lake and try and better understand this process and also understand how we're going to explore when one of you gets to an asteroid or to Mars.
When you land on another planet, you are going to be inside a little spaceship that protects you from that environment, and at some point you're going to have to open the hatch and go outside and explore. When an airliner lands in Canada, you're nice, all tucked inside, and at some moment the door opens and you walk outside and you're in a new place. Same thing on another planet. How do you prepare for that? How do you simulate that so that it's going to be realistic enough and familiar enough that just like the guys in the Hubble telescope, so that when they go outside they know what's going to happen next? Well, we could simulate it in a pool, but normally when you're training in a pool you only do something for a few hours, maybe 6 hours maximum. But when we land on another planet, that's where we are. We are no longer from Earth, we're now from Mars. We're Martians, we're living in another world. And you need to get the crew simulated into the mindset of being on another world. And so we have a simulation under the ocean in the United States where you go down and you live 20 or 30 meters below the ocean, and you live there for weeks. And you are no longer going to restaurants at night and staying at home with your family. You are now a crew that is physically separated from the rest of humanity, both technically and psychologically. And it makes you look at your simulation differently. And when you go outside of that habitat, you are weighed down with the right amount of weight so that you move around on the surface as if you were on the moon, or as if you were on Mars, or even exploring the surface of an asteroid. And the mark of a good simulator is that it can fool you into really thinking that you're there. And by that fooling process, you can then get the right lessons. You can think of the right things. It'll occur to you, go, wow, I didn't even think about that. You know, we need to change that piece of equipment because it won't actually work. I just realized when you go and try it out in the simulator. So that's why we create as accurate a habitat as we can. And it would be hard to live underneath the pool in Houston for weeks and weeks at a time. We use the pool for all other types of training. So that's why we do it on the ocean floor off the coast of Florida.
We also live underneath the ocean as part of our simulation and training. And I'm going to spend most of the month of May living under the Atlantic Ocean.
In order to train for living on the bottom of the ocean, first, of course, you need all of the technical training. How to be a scuba diver, how to work with different mixes of gases, all of the first aid training, cardiovascular training, medical work, theory, all of those things, and then how to interact with all of the machinery, all of the life experiments that are going on. So some of those things take months, some of them take weeks. We will actually go to Florida about a week in advance just to get the final training, to go look at the habitat, and so after the final week, sort of like your graduate studies, then we'll actually go down, we'll be convinced that we will be safe and we will be efficient, and we'll go down and start to work. And then it's very busy days. We have a full schedule with every minute choreographed. We go outside on 44 spacewalks in the 2 weeks that we're down there, 11 for each of the 4 astronauts that are going outside. So there's lots of stuff to do every day. It'll keep us really busy for the 2 weeks. And then you have to come up very, very slowly because of the pressure on the body. It takes a full day to come from the bottom of the ocean just to the surface. And then you have to stay in Florida for 2 days just to let your blood readapt to being at sea level. And then we'll leave Florida. So all in all, it takes about a month.
And we simulate that as if we've just landed on another planet. And we go outside, and we put the right amount of weight on the suit that it's the same sort of gravity as if you were walking on the moon, 1/6 the Earth, or walking on Mars, 1/3 the Earth, or even an asteroid where you basically have no gravity at all, virtually none.
NEMO is in the Aquarius habitat. It's the actual name of the building that's on the bottom of the ocean. Aquarius, for the last decade or so, has been fixed on the sea just south of Florida. The nearest part of Florida is Key Largo. So if you drive an hour south of Miami, that's about where we start on land. We go out many kilometers offshore, and then there's a buoy sitting there in the ocean, and we get off the boat, and we swim down, and there on the bottom is a spaceship, basically. And we go inside this spaceship, there's a bubble of air inside it, and that's where we live for weeks at a time.
We have to develop spacesuits and how they work. We have to develop surface rovers. So here's an actual surface rover we're building. There's a drawing of how it would look on another planet, and then here's the underwater mock-up, so we can test human interfaces, how to move things up and down, how big can things be, how heavy can things be, trying to develop all of the techniques from when one of you goes and does it for real.
NEMO 14 is a team of 6 people, a mixture of astronauts, PhD researchers, and technicians. There are 6 of us on board, and I'm the commander of NEMO 14, so I'm taking care of all of the operations, taking care of all those people, taking care of the safety, and making sure that we are as productive as possible over the 2 weeks that we're living under the ocean.